So I'm going to try to go through this sort of quickly. This is a titanium part that we have. I can show you the part that we're going to be making in here. I'm using VERICUT version 9 to do this. So we have that, and then the NC file that's sitting in here as well. I can show you that. So it's just a bunch of G codes and a handful of tools. And by looking in the tool manager, just like I was talking about earlier, if you download tools like from Machining Cloud or something, they will have technology data associated with the cutters so that it knows how that tool is supposed to perform. Each tool has a different set of values, chip thicknesses, and that go with it. And so in VERICUT, what I'm going to do is something kind of different here. I'm going to, while I'm verifying my job, I'm going to go ahead and tell VERICUT to optimize it at the same time. And as I run my simulation, we can go ahead and let it cut. And believe it or not, even as fast as you see this cutting, VERICUT is running all of the optimization, the analytics, the statistics, everything is happening behind the scenes. And my ultimate hope as a programmer is, while I'm watching these codes and spindle speeds and that, is VERICUT's going to take care of all the feeds and speeds and all that for me. And I don't have anything to worry about. And when I'm done verifying my job, I'll have an optimized program ready to go. And if watching it isn't your thing, you can just kick up the slider there for the speed and just let it kind of blast through the code and get through it as quickly as possible, or you can turn off the graphics updates altogether if you want. You'll see some red error messages down here at the bottom. Those are symptoms of problems that you had in your process. And at this point right here, since we optimized, VERICUT's telling me what the results are. So I'll go over those really quickly, and then we'll look at these charts a little bit. This part ran an hour, and it's down to 25 minutes after optimization. And that's a pretty significant savings, as you see here. So if I just kind of play through this little calculator and say, okay, I make 100 of these parts, that saves me about 60 hours, almost 61 hours of machine time on this particular part run. And even with just a handful of machines, I've selected 3 here and only running them one shift, I can see that I'm going to make about $300,000 in savings, just doing what I did here. So that's pretty handy to have. The other thing I wanted to show you is these charts are actually very interactive. So when you're looking at these charts and you're trying to understand what's going on, we'll take a look at just one tool here. There's a huge spike over in this area here. I've got a couple of different colors going on here. I'll explain them to you real quick. The dark green is the original program. The bright green shows me the gains I made through optimization. And the red shows me where the original program had to be brought back down to get it to run successfully. So green is good, it's what we want. Red is saving our machine or saving the tool from potentially breaking or damaging the part. If I just look at the original program, these are the analytics I talked about with the force charts. So people have the guideline of where this tool should be running. They can judge their NC program and see, well, geez, this doesn't really look like it's very efficient. It looks like it's not running where it should, and they'd be right. But in this area, they've completely overrun the tool. Somebody misprogrammed a feed rate, and that's a real potential for problems there. And if we just look at the optimized side of it now, you'll notice chip thickness is right where it needs to be, where it should be, and we've got forces never exceeding the maximum that tool can recommend. So we got kind of the best of both worlds there. For those of you who are force optimizers, and you actually are working off of charts like this, when you find an area of interest that you want to use for settings, you have this handy little right-click option here to save those values to the tool. And I won't get into setting up right now, but that's a real easy way to pull values right off your charts and send them into the tool manager for use with that tool. But really, that's how easy it is to optimize a program. And in this case, it might be interesting to see, what actually happened for this job. So I've got one of my reports that I might be getting ready for the shop here. So I'm going to go ahead and get that saved. It wants to know who I am, so I'll give it my name and give it my part number. And then we'll go ahead and save that through here. So the report that gets generated is this one happens to be a PDF style of report. It's got a setup image, which is really easy to make in VERICUT. And then it tells me the files are used. It gives me my optimization savings. The shop now knows what runtime they can expect when they run these jobs. Here's something you shouldn't see, errors and warnings in there. We got to clean those up. But basically, now I got a tool-by-tool runtime. So even on a shift-by-shift basis, I can tell how long a tool is going to run and the savings for each. And here is the overall impact of optimizing this particular titanium bracket part. So pretty useful information.